Good morning, everyone. This is Rick Murphy with AllNet Distributing. Thank you for taking the time to join us today for the weekly webinar series. This week, we've got with us Seth Powell. Seth is the sales engineer of the AV over IP division of Atlona, and we're going to be reviewing the OmniStream AV over IP family, the OmniStream Pro and the OmniStream Type R. And then Seth's also going to talk about the Velocity, which is their control platform that doesn't require like a third-party control system like an AMX or a Crestron or a Control4 in order to operate these systems. So just some quick notes about the presentation. We always have everyone muted. So if you have any questions during the presentation, please feel free to type them into the questions tab. You should see a dashboard on the right side of your screen. One of the tabs says questions. Pose the questions in there, and then I will narrate Q&A toward the end of the presentation. So please stay to the end to hear your questions addressed. And also, any of you on the call who have CEDIA certified staff, any live attendance of an AllNet webinar is worth 1/2 CEU credit toward renewal for your CEDIA certifications for your staff members. If you have any questions about redeeming the CEDIA CEUs toward your renewal, please feel free to reach out to me or reach out to Bill Zidek here at AllNet. My email is rick.murphy@allnetdistributing.com, or reach out to Bill at bill.zidek, and that's ZIDEK, at allnetdistributing.com. Seth, the floor is yours.
All right, thanks a lot, Rick. So as Rick's, my name is Seth. My primary role at Atlona is senior sales engineer, and he's correct in saying the AV over IP division as well. They essentially hired me 2.5 years ago to really focus heavily on sales engineering of our AV over IP products. At the time of them hiring me, I was one of the first people that they brought in really as an AV over IP focused role. We've now brought in quite a few individuals actually who are pretty experienced in this particular field. So today, really the goal is to bring you guys up to speed on our product line, what our product offerings are in this AV over IP space. And before we get into the actual products, I want to also kind of talk to you about what our thought process was in developing this product. And the reason why that's important is because in the AV over IP market, as some of you may know, if you're familiar with this space, it's unlike a lot of other product categories out there in that there has been very little focus put on sort of honing into standards, if you will, for this particular market space. Meaning that if you look at something like an HD-based product, for example, every HD-based product out there in the market is based on the Valens chipset and the chipsets that Valens produces. And so every single product, regardless of who the manufacturer is going to be very, very, very similar in terms of its features, in terms of its limitations, in terms of its specifications. But with the AV over IP market, that is not necessarily the case, at least not yet. So it's kind of the Wild West. And as if some of you guys are familiar with this particular space, you've probably seen that. You look at Crestron, you look at Atlona, you look at SVSI, you look at Just Add Power, all of these different names that are in the AV over IP market space today. We all kind of bring something a little different and a little unique to the table. So it's really not one product fits all currently, and as unfortunate as that is, you really kind of have to know what you're looking at with this stuff. So I aim to kind of inform you guys of that stuff, inform you guys of where really we would be a good fit, and also, of course, talk about our products. So let's dive in. So first, we're going to start with OmniStream. OmniStream is our AV over IP product. And as you guys may or may not know, the number one, I guess, the meat and potatoes, if you will, of any AV over IP product is going to be the compression codec. Now, there are several considerations that you would potentially make if you were choosing a compression codec for the AV vertical. I've got 3 listed here, but I'm going to name 4. I've been actually meaning to update this slide to have all 4 of these on there. But so the first 3 that you see here: latency, implementation cost, and image quality. But the 4th one I'm going to add is bandwidth. Bandwidth is also important because that's also a big differential across the board on what these products are doing today. So let's go back to latency. That one, should be relatively obvious. Latency meaning the time that it takes for the signal to go in the input side and out the output side, right? So from your source out to your display, what's the elapsed time between those two things? If you think about, plugging your laptop into, let's say, an HD-based matrix system, for example, when a user walks into a room and plugs their laptop into an HD-based system, they don't expect any latency really, or any perceived latency, right? Of course, there's going to be some latency there in terms of just the processing time it takes for something to go from one side to the other. But that latency is going to be negligible. It's not going to be noticeable. It's not going to be perceivable. For the particular market that we were looking to target with our initial offering, that would be the large HD-based T-Matrix market space. We wanted the user experience to be similar enough on our product that a large HD-based T-Matrix would be interchangeable with our AV over IP solution. So latency was really, really important. The other thing that was going to be really important for us was image quality. Again, the example of the HD-based T-Matrix, you plug any source into an HD-based T system and you expect the image quality to be also negligible, right? Negligible to the point that there's no differences between the original signal and the signal on the other end of the HD-based T system. We're not doing any compression, or we don't want to see compression, right? I guess is what I should say. There's a bit of a myth in the AV industry that compression is bad, and I can talk about that a little later, but that's not necessarily the case. What we want is we don't want to see the compression. We don't want to see artifacting in our image as a result of the compression. So we want that image quality to be as pristine as possible as well. Implementation cost is important because, of course, going from an HD-based T world where transmitters and receivers, I guess, as they're called, are going to be a couple $100 a piece, maybe max, into the AV over IP space, where it's not uncommon to see encoders and decoders at $1,000 a piece. Obviously, implementation cost is important because we don't want to make a product that's $3,000 each for an encoder or decoder. So we need to find ways to make this that are going to be cost efficient for us as well, so we can pass those savings on to you guys and create a product that's going to compete in the same space as HD-based T. And then lastly, I mentioned bandwidth that's not shown here, but bandwidth is hugely important as well. Where it's really important is deciding what exactly you want to do with the stream once you compress it and send it out over a network. Is this something that you want to stream within a local area network, just within the building? If so, when you're using this in the similar way as the HD-based Matrix, going back to the example I've been using, streaming within a building is all you really need. And when you're streaming within a building, it's not uncommon to see 1 gig or even 10 gig networks sometimes in these applications in building. When you're streaming outside of a building, though, and you're going to remote campuses, if you're going to other houses, guest houses and things like that via fiber connections, and especially in the case where you want to stream out to the open web in some instances. In these instances, we can't be streaming at 1 gig or especially at 10 gigs. In those types of scenarios, we need something closer to 5 or 10 megs maybe. And that's where a compression codec such as H.264 is going to be useful. Again, when we introduced this product line, we introduced it. We wanted to cater towards this market that was similar to large HD-based T-matrix switchers. So because of that, we chose the 1 gig path because we feel like that's a really that's really a standard for any new home installation or any sort of new corporate or enterprise application that's being built. 1 gig is at least the standard, if not, like I said, sometimes 10 gig. So those are the considerations that you would necessarily make when you're choosing a compression codec for the AV vertical. So what did we choose? We chose a compression codec called VC2, or also known as Dirac Pro. You may or may not have heard of this one. It's not as popular as some of the other ones. You have things like JPEG 2000, H.264, H.265. Those are the really popular ones. VC2 is a little less popular. It is actually an open source compression codec. It was developed by the BBC in 2008 because they wanted to stream the 2008 Olympics in 4K, but they also wanted to stream that royalty free. So going back to this implementation cost, that was a big motivator in why VC2 was created to begin with. They just did not want to pay anybody royalties to be able to use this, so they created this open standard. You can look this up online. It's a SMPTE standard, SMPTE 2042, and just a couple little specs about this. VC2 supports 444, 422, and 420 chroma subsampling up to 16-bit. It does support up to an 8K resolution, believe it or not. There's some talk about 8K right now. Of course, it's not really important to us in current day because there's no content that's 8K yet. But that stuff is coming down the pipe. HDMI 2.1, I think it was announced a couple months ago, and 2.1 is now going to support 8K. So over the next couple of years, you will start seeing content come out for that. That's not to say that our OmniStream products are 8K ready. They are not, because they only have an HDMI 2.0 chipset in them. So we're bound by the limitations of the HDMI chipset. But the good news is that that's the only thing that we're really bound by. We're not bound by processing power. We're not bound by our compression codec in VC2 here. So really, once we get to the 8K realm, the only thing we would necessarily need to do would be to swap out that chipset, and we would be an 8K ready solution pretty simply. And then lastly, and potentially most importantly, is our ultra low end-to-end latency with VC2. And just as an example, it's streaming at approximately 9 milliseconds. It's technically a little less than 9 milliseconds for a 60 hertz video, and that's end-to-end latency. So that's extremely, extremely fast, completely negligible. You absolutely cannot tell the difference when you look at those two images, uncompressed and compressed side by side. So let's take a quick look at the OmniStream Pro product family. So back about 2 years ago, when we first released OmniStream, OmniStream Pro product family was just called OmniStream because at the time it was the only OmniStream product family that we had available. There was no OmniStream R-Type, there was no OmniStream USB or OmniStream Audio. It was just OmniStream Pro, or what we called OmniStream at the time. These 4 boxes right here were our initial offering. It is really just encoders and decoders, but we offer single channel and dual channel in both encoders and decoders. Now, as you can see, there's absolutely no difference in the footprint of these boxes and how large they are. They are a half rack width wide, and about, I think about maybe 6 inches deep, something like that. So they're not very large boxes. But what we do is we fit 2 discrete channels into a single box with the dual channel units. So you'll notice that really the main difference between these two boxes from a physical appearance is just that the single channel has a single NIC on it, a single network port, and a single HDMI port, whereas the dual units have dual NICs and dual HDMI ports. And I'm going to talk in just a second about why we have dual network ports, or why we might need dual network ports. So that's our OmniStream Pro product family. So let's look at the OmniStream Pro features and what features we offer with this product. At the very top there, high quality 4K UHD. Personally, I think that offering 4K and UHD compatibility is necessary on any product line that any AV manufacturer is releasing these days. And I think that really the only reason any manufacturer would not include that at this point would be if they were just trying to create a very, very budget-friendly solution. This is still a pretty budget-friendly solution, but we are offering 4K UHD because I think it's necessary in most of the markets that you guys are working in, and most of the markets that we're selling in. To the left, multi-channel. Really all that means is that we have the dual channel units that fit in a single box. There are not too many manufacturers out there that are offering this sort of high density encoders and decoders. And the main reason that really matters is it saves space. At the end of the day, it saves space in your rack. If I've done some math before on some of the competing product lines out there. I know there's a product line that offers a card-based solution, maybe a couple of product lines that offer a card-based solution. Generally speaking, ours are fit in a similar, you can fit a similar number of encoders and decoders in the RU that chassis would take up with our dual channel units, if not more. On definitely a couple of occasions that I've done some comparison work, we've been able to fit more in the allotted rack space than the competition with these high density units. Continuing down, content encryption. Again, another personal thing for me, I think that any AV product that's going to be going on a network pretty much has to be encrypted, and I think that's a pretty fair assumption across the board. I think most manufacturers agree with that. So this is not a factor that's different for us. It's just another one of those things that I put this on here to say, hey, we have this as well. Most manufacturers have this. We also have this because I think it's important. So just so you know, our content is encrypted end to end. We're using AES 128-bit encryption end to end. Ultra low latency. I mentioned sub 9 milliseconds for a 60 hertz video. It's important that I do include the 60 hertz part because that does change depending on the frame rate of what your content is. But suffice it to say that the calculation on that is our latency is less than half of a frame from end to end. So that's really important because most of the competition, at least in this space, in this 1 gig space, is streaming significantly higher latencies than that. Most of the competition sits at about 30 milliseconds for a 60 hertz video, and so us being sub 9 milliseconds is huge. Now, to give you an idea of what the difference between those two looks like, if you have a gaming system, for example, an Xbox or a PS4 or something like that, and you are playing a game, anything over about 20 to 24 milliseconds is going to be significantly noticeable in lag time or in latency on that video game. You're going to feel it when you're trying to move your character around in the game, or trying to do things in that game. You're going to feel that latency. Anything less than that mark, about 20 milliseconds or so, is not going to be noticeable. So that's significant. Just a quick real world example. We had a customer who was looking at speccing Just Add Power for a soccer themed bar. They were a sports bar they were building, and Just Add Power worked literally perfectly for all of their video distribution. It was exactly what they wanted. And if you're not familiar with our pricing versus Just Add Power pricing, suffice it to say that our type pricing is just slightly more than Just Add Power. It's not significant, you know, and of course we work on project flips like that, so you know we can be competitive on pricing. But they were going with Just Add Power just for pricing for the most part. And what it boiled down to was they had a couple VIP booths. And in each of these VIP booths, they had a PS4 and they had a soccer game that was constantly in those PS4s that their guests could, you know, choose to play the soccer game if they wanted to. Well, they got the Just Add Power stuff on eval to test it out, and it worked perfectly for everything except for the soccer game, and it was completely unusable with the soccer game. They said, you know, either we've got to do away with the soccer stuff, or we've got to change, you know, to a different solution that's going to allow us to do this. And they ended up going with OmniStream R-Type because it was, you know, significantly faster, and the latency allowed them to be able to play this game, you know, unimpeded. So just a little real world example for you. So moving on around cost, you know, again, with our low implementation costs, we're able to pass those savings on to you guys. Not to mention that on Pro, the high density units, the dual channel units, if you do a cost comparison by port, which is kind of how you should do cost comparisons amongst AV over IP products, meaning that, you know, if you take a competitor's product that has one input and you take our product that has two inputs, you have to divide our product's cost in half to understand, you know, what the cost differential between the two actually is. We have a very competitive product. We're not the cheapest product on the market, but we're not the most expensive product on the market. And with those dual channel units, we're actually giving you a price break per port when you go to the dual channel units. So the dual channel units do actually work out to be a little bit cheaper than the single channel units. So that's another cost savings we're passing on to you guys. Moving on around PoE, PoE is not, you know, it's pretty common in the AV over IP space. It's not something that we would normally put on these types of, you know, feature charts. But the reason we have is because in doing our competitive analysis amongst a lot of our competitors, what we've realized is that standard PoE is not really the norm in this industry. It's really not. A lot of what you'll see is either PoE plus or even a totally proprietary PoE standard. Some of our competitors have require 35 plus watts of power, which means that you can't use standard PoE offerings from a simple switch to power these products. You have to buy, you know, that competitor's proprietary power supplies or proprietary power injectors in order to actually power those products. That, of course, adds to the cost per unit. It also adds to the amount of space that you're going to take up in a rack. Our units use standard PoE. Both of our boxes are powered on about 13 watts per unit. Standard PoE is 15.2 watts. So you can use standard PoE and power all of our units. So that's a pretty cool little add-on. Air resilience. Air resilience is something that's relatively unique to our product. I think there's one or two other manufacturers that are doing this, but we're using something called forward air correction. Forward air correction allows us to essentially calculate a checksum on the front end and transmit that checksum alongside the original packets. And when it's received at the receiving end, that receiving end will effectively, you know, look at those checksums, and if we've dropped any packets along the way, it can recreate a bit exact version of those packets in real time on the receiving end without giving you any artifacts whatsoever on the screen. We can correct up to about 12% packet loss using forward air correction on our product. And that's a big deal. 12% packet loss is a lot of packet loss. If you have more packet loss than that on your network, then you've got bigger fish to fry, so to speak. So that's a pretty cool feature that we offer on the Pro product line. And then lastly, redundancy. So I mentioned earlier that I was going to get around to why we have these two network ports on our product. Redundancy is the big reason. So what redundancy means is it means that you can take network port number 1 to one network switch or your primary network switch, and network port number 2 to your secondary network switch, and have a fully physically redundant system at that point. Anytime that one of your switches goes down or one of your streams goes down for whatever reason, the decoder will automatically detect that on the decode end, and it will immediately switch over to the secondary multicast stream from the secondary switch with about 1 second or so of drop time in your image. So your image drops out for about a second, and your image pops right back up and resumes right where it left off. That's an incredible feature for lots and lots of different applications. I don't think that you would really see this a lot in the residential market, but we've sold a lot of these redundant systems in things like network operation centers, government work, things like that. So let's move on to R-Type. So after we announced OmniStream Pro, as you guys may or may not know, we have a commercial and a residential side to our business, and we pitched OmniStream Pro to both markets, and commercial said, this is great, this is exactly what we've been looking for at the price point we're looking for, perfect. And OmniStream R-Type, residential market said, hey, this is perfect, this is exactly what we've been looking for, but there are some solutions on the market that are significantly cheaper than your solution. And so this is going to be a pretty hard sell for us. So our response was OmniStream R-Type. So what OmniStream R-Type is it's exactly OmniStream. As you can see, the boxes are identical. The guts of the boxes are identical, but we've stripped some of the features so that we can offer this product at a very reduced rate to compete in that residential market with those other residential focused products that are out there. So instead of offering dual channel and single channel encoders and decoders, we offer a dual channel encoder and we offer a single channel decoder. And that's for one reason and one reason only, and that's because in the Pro product family, we sell mostly dual encoders because a lot of times sources are all together in a rack, and we sell mostly single decoders because most of the time people are just putting a decoder behind a display. So no real reason. Well, and we don't have redundancy. Redundancy was a feature that was taken out of R-Type. So since we don't need redundancy, we don't technically need the 2 network ports on both the encoder and the decoder. So we only made these 2 products. So that's our product offering for the OmniStream R-Type product family. So let's take a look at the features. Obviously, a reduced feature set. You'll see over on the right-hand side, ultra low latency. The latency on this product is identical to the latency on OmniStream Pro. It's no different whatsoever. It's the same compression codec and the same chipset, so it operates exactly the same. You still get sub 9 milliseconds of latency on a 60 hertz video. Pristine quality video. Again, image quality is exactly the same as it is on OmniStream Pro. 4K HDR. Now, this was a feature that was unique to OmniStream R-Type when we first released R-Type, because obviously HDR and Dolby Vision, which is important now. That's a feature set that we have available on both products. Neither one of those were available on OmniStream Pro when we first announced R-Type, but both were available on R-Type out the gate because we knew that those things were important to the residential market. They're less important for the commercial market. So that was a unique feature at first. Now it is a feature on both, but we do offer 4K HDR, so HDR10 as well as Dolby Vision support. And then this at the bottom here, fast motion optimized. So this is the only thing on this feature wheel currently that OmniStream Pro doesn't have out of the box. What fast motion optimized means is we are using a very specific set of wavelets to model the signal whenever we do our compression. Those wavelets are specifically used for full motion video. So suffice all that to say that this product is optimized for use with full motion video sources. OmniStream Pro out of the box is optimized for static images, static video. So PowerPoint presentations, Excel, laptops being plugged in, that sort of thing. Whereas this is optimized for full motion video, cable box, Apple TV, Netflix, all that good stuff, you name it. OmniStream Pro, being the more advanced feature set version, does have the ability with an internal, or I should say a software-enabled button where you can turn that to R-Type mode and reboot that product into R-Type mode and use the Pro unit as an R-Type unit. You can do that if you wanted to use these things cross-platform, but R-Type does not have the ability to be transformed to a Pro unit once you buy that unit, just as a heads up. So OmniStream specifications in general, in terms of their video chipsets. I'll point out just the differences here. So up top, you'll notice that I've got the resolutions that these things support, and you'll notice that I've got R-Type in parentheses for 420. That's because R-Type only supports 420 chroma subsampling. Now, somebody might say, hey, I really, it's important to me to have 444. My question would be, what kind of content are you pushing? If you're pushing static content, as I mentioned, that's what OmniStream Pro is optimized for. So I would recommend OmniStream Pro for that automatically to begin with. If you're not pushing static content and you were pushing full motion video, which is the majority of what we see in residential and light commercial, in that case, 420 chroma subsampling is perfectly fine. If you're not aware how chroma subsampling works, what it is effectively the act of sampling out bits of color information in order to reduce the signal size. That's the reason that's okay. It sounds bad, we're sampling out pieces of color, parts of the color information being transmitted. But the reason it's not that bad for full motion video is because our eyes, the way our eyes perceive detail is we perceive detail in the luminance information or in the black and white information. We do not perceive detail in color information. So we're able to sample out some of that color information and still get an image that looks exactly the same as it did before for a full motion video. Where do we see those artifacts, though? If you were looking at a static image, if you're looking at something with a lot of fine line detail or maybe a lot of text, for example, static text, then you're definitely going to start to see artifacting in a 420 image. But just to set your mind even more at ease, if you go out and you look at a lot of these consumer grade displays that are going into these types of light commercial and residential applications, most of these consumer grade displays only support 420 anyways. So regardless of whether or not we're sampling at 420 or 422 or 444, a lot of these displays that are available to that particular market are 420 only anyways. So moving on, rate control.
Hey, Seth.
Yeah.
Hey, Seth. Yeah. Hey, just a quick anecdote here. So David Meyer, who's the HDMI subject matter expert over at CEDIA, he noted one time when that question came up about, well, why is it important and is it a compromise? Ultra HD Blu-ray, which it's pretty much everyone's kind of benchmark for video quality. Every single title is encoded 420.
Yeah.
So probably the best video that any of us has ever seen most likely was encoded as 420.
Yeah, great. That's good to know. I might use that one moving forward in other trainings. Thanks, Rick. Appreciate it. Okay, so moving on down the list here, rate control. You'll notice that it says capped VBR for Pro and constant bit rate for R-Type. So what are the difference in these two? Capped VBR stands for capped variable bit rate. That means that variable, because we have in the software, we have a dial, essentially. We have a rate control. We can tell that, we can specify what bit rate we want this to stream at. Now, capped variable bit rate, because we're not telling it specifically what we want it to stream at constantly, we're setting the upper bound. So if you guys, if some of you guys are audio guys, this works exactly like a limiter works in the audio world. We set the upper bound and we say, don't go above this, and it's a hard limit. Whenever we hit that limit, it never streams above that. If you're streaming constantly at that limit, at whatever that limit is, let's say I go in and I say, okay, I want to stream at 100 megabits per second. 100 megabits per second for, let's say, a 4K image is going to be a very, very, very and you're going to be constantly hitting that bound, and you're probably going to see lots and lots of artifacting. It's probably going to look like complete garbage, to be totally honest with you. But if you set that limit at 900 megabits per second, just below that 1 gig max, then you're not going to see any artifacting in a 4K image. In fact, you probably would never even get to that point where you're streaming at 900 megabits per second. Moving over to constant bit rate for R-Type out of the box is set at a fixed 900 megabits per second. There is no dial in the software. There's no way to change that bit rate, and everything constantly streams at 900 megabits per second, regardless of whether or not you're looking at a still image or you're looking at a full motion video that's changing every half second. It's still going to be a constant 900 megabits per second on the output of that encoder. So that's another big difference. Let's see, audio, embedded HDMI, analog balance, decoder pro. So that's one difference. The OmniStream Pro units have an analog balanced output on the decoder. The R-Type units do not have that analog output, and I'll get into that in a minute about why that is. I've got I think the OmniStream audio slide is next, so I'll go ahead and jump right into that. Yeah, there it is. So we have two products in terms of audio for this particular line. The Omni 232 is our 2-input, 2-output Dante audio bridge. This is literally 2 mic or line inputs and 2 line outputs. There are a lot of companies that offer this type of a product. Ours is no different. It's just a Dante on-off ramp for using with other Dante-enabled products. What's probably going to be a little more useful for you guys is going to be this Omni 238. The Omni 238 is effectively an audio-only decoder. It has 8 stereo channels or 16 mono channels, depending on how you wanted to use it. It does do full down mixing, full audio down mixing. And this will just be a standalone unit that you would put in a rack near your AVR or near your DSP or whatever you're going to use for audio to pull your audio off of the network coming in from any of these encoders and decoders. So as I mentioned, this thing could decode mono audio from 16 different decoders or 16 different encoders at once, or it could pull in 8 stereo channels from 8 different encoders at once if you wanted it to. So that's going to be your your dedicated audio piece for those systems where you wanted to utilize an AVR or a DSP in the rack along with some of your source equipment. OmniStream USB. This is not going to be super pertinent to you guys, I don't believe, but we do have, this is effectively USB encoders and decoders. We have the 311, which is a USB host to IP adapter. This is where your computer would plug in, and then we have the peripheral device that has 4 USB inputs for USB peripherals, such as microphones, cameras. It could be interface devices such as mouse, keyboard. It could be storage devices, whatever it is that you wanted to link to your computer from a long distance away. You could do all that over the network with OmniStream USB. And the reason why we introduced this product line is to introduce something to the commercial world called the All IP meeting space. And I'm not going to spend much time on this, but the long and short of it is using our OmniStream product line as in terms of audio, video, and USB, and then also using our velocity control system, we can build a conference room system or a meeting space system that's going to be all over the network. So as you can see, I have my AV LAN here in the middle, and literally every single product is plugged just into the network, right? So you have a network switch, everything gets plugged into the network switch, and then you have a full meeting space system, soft codec conferencing system all over the network that's infinitely scalable and expandable depending on the customer's needs. So that's a pretty cool concept that we've been really talking a lot about in the commercial world. Something that is going to be maybe a little more useful to you guys, both OmniStream R-Type and OmniStream Pro have video wall capabilities. We can do a simple configuration of up to a 5x5 video wall utilizing our Velocity or AMS. Within Velocity or AMS, we have an OmniStream video wall configuration tool that's literally makes this video wall configuration drag and drop. It's very, very simple to use, and you can configure up to a 5x5 video wall using that configuration software. If you have a larger video wall than a 5x5, which is pretty big, you can do up to a 16x16 video wall using the OmniStream API, meaning that you can log into each of these individual decoders and set them up for video wall and do all the math and set the parameters yourself and build up to a 16x16 video wall. So that, that's absolutely massive. I've never heard of anybody doing a 16x16 display video wall, but hey, I'm sure somebody out there is imagining this right now and putting it together. So we also offer full bezel compensation with our video wall, as well as 180-degree image rotation for when you want to flip the monitor upside down. If the bezel on the bottom is very thick and you're doing a 2x2 video wall, you could just flip those top displays upside down so you can butt those displays as close together as possible so you don't have a large gap in your image. And then preset recall. Within Velocity AMS, you can build these video wall presets. So for example, on this 3x3 that I'm showing here, if I wanted to do a video wall with the 4 displays in the corner, and then each display on the bottom and on the right side were going to be individual images, I could make that a preset, and then I could make the full thing a preset, and then I could make all 9 monitors have different content and make that a preset. And I could be able to recall those presets just via, a third-party control system or Velocity, our control system, which is pretty cool to be able to do that so quickly. All right, so we have a system called AMS. Stands for Atlona Management System. AMS is our means of configuring and managing all of our IP controllable products. For OmniStream, however, why this is important is because this is going to be your tool for foolproofing the configuration and the installation of this particular product line. As you can imagine, anybody that's buying an OmniStream system is not buying 1 or 2 OmniStream boxes. They're buying quite a few, right? Even if you have, I don't know, let's say 6 sources by 10 displays, that's still 16 individual boxes. Well, actually, it would be 13 because you have dual channel encoders. So it's still 13 individual boxes that you'd have to go around and configure individually. And that could be a huge pain. And there's a high chance that you're going to make some sort of small error when you're going in and configuring those manually. So to make that super stupid easy, we have AMS, Atlona Management System, which allows you to essentially log in, auto-discover all of the units that are sitting on the network, and then auto-configure all of those units. And literally all you have left to do is this third piece here, routing. You click on, there's a virtual matrix routing page that just gives you cross points between all of your encoders and decoders, and you point and click to route video, audio, or control. So it's super, super easy. That's how you set up OmniStream. Generally speaking, we say that you can have OmniStream up and running in 30 seconds per box. Is usually the benchmark that we give people for being able to configure OmniStream utilizing AMS. Now, we do also have Velocity, which is our control system that I'm going to talk very briefly about here in just a second. With Velocity, people ask me a lot of times, how do I know when to spec AMS and when to spec Velocity? What I usually tell people is, if you're utilizing Velocity for control, you don't need to spec AMS. AMS is going to be pretty redundant in that sense, and very soon with the next release of firmware, Velocity is going to be completely redundant because we're going to actually build the AMS functionality into Velocity as a separate page. But for the time being, Velocity still does all of your auto discover and auto configure stuff without needing AMS. However, if you're planning on using a third-party control system, such as Control4, Savant, Elan, you name it, then in those instances, because you aren't going to have the configuration tools available to you via that third-party control system, I highly recommend picking up AMS. The good news is that AMS is available on our website for the low cost of free. So you can download an instance of AMS onto your laptop if that's how you prefer to use it. If you would prefer to have it be a standalone PC of sorts, then you could buy what we call our AMS HW. That's a little hardware box that you could install in the rack at the customer's location, so that that's there at all times doing monitoring and management of that system. You could also set that up to allow you to remote into it from your desktop or something like that. Now, really briefly, actually, I want to go back. Rick just reminded me that we want to mention QSC integration. So there are actually quite a few different manufacturers of DSPs that we've worked pretty tirelessly with to create a very seamless integration with our products. OmniStream specifically being the first one that we really started trying to make these partnerships with. QSC was one of the first DSP manufacturers that we worked with. So where we're compatible with QSC would be basically both of our OmniStream units, R-Type and Pro, have native AES-67 audio integration. AES-67 is a standard of sending audio over a network, and QSC also has AES-67 integration, meaning that we can pull in audio directly into any QSC device without any third-party products or any additional products from us even to assist with that. Literally, as long as the QSC device is sitting on the network and our OmniStream devices are sitting on the network and they're all talking, we can pull that audio directly into the QSC device. We demo this at all of our trainings. We have a QSC 110F that sits in our rack, and we demo that functionality at all of our trainings. I've personally set it up many times. It's very simple, very straightforward, and yeah, so that's a pretty cool advantage to using OmniStream alongside QSC. All right, so I'm going to do, before I go to questions here, give me 5 minutes to just tell you quickly about Velocity and what it is, and then we'll do a little bit of Q&A. So Velocity is our control system. It's a bit of a different approach to control. As you can imagine, a manufacturer, an AV manufacturer getting into the control market at this point in time, it's a high barrier to entry. Because there are a lot of products out there that are time tested, that people love, and that people use on a regular basis. So to convince someone to move to our control system is not exactly an easy feat. We knew that we needed to do something a little bit differently to sort of entice people to look at using our boxes, rather than somebody else's. So that approach is one that we call a decentralized control approach. So the traditional control approach, most other manufacturers are going to be something like what you see here. If you have, this is a university example, if you have a university that has multiple rooms that you want to control, you go in each one of those rooms, you count up how many devices that you want to control, and you spec a control processor that will control exactly those devices, and you have to do that for every single room. So if I have 4 rooms that I want to control, I have to buy 4 different control processors. I have to configure each of those 4 different control processors, and that's just how I go in and how I build my control with those systems. The decentralized approach would, or the Velocity approach, would be something like this. Everything's already on my network within this building. All I really need is one control processor, and as long as I can differentiate between these rooms within this control processor, I can control all of the rooms from the same control processor with different user interfaces, with different touch panels or phones or tablets or computers or whatever my means of controlling that system is going to be. So that's the Velocity approach. The device that you see there is our control gateway, or our processor, really. That's our VGW250, the 250 meaning that it can control up to 250 unique IP addresses at once. So 250 devices, you do the math, but that's a lot of devices. You know, if you have 10 different rooms, you can control 25 different devices in every single room. You know, I'd say you'd be hard pressed to find an AV room, an AV control system that's controlling 25 devices in a single room. So, you know, this box can do lots and lots and lots of rooms from a single box. The different components of a velocity control system. Velocity control suite is the suite in which you go in and configure and control configure and manage all of the different rooms and all of the different technology that you're controlling. That velocity control suite is an embedded web page on the gateway itself. So this is not a software that you have to run on your laptop, that you have to go out and load drivers or load content to that processor over and over again. This processor sits on the network, and it, you know, gets constant firmware updates with all the latest and greatest drivers, all the latest and greatest features that we have to offer. And Velocity Control Suite, you just log into the gateway and do all your configuration right there on the gateway. Of course, the Velocity Control Gateway is a big piece. We have that VGW250 that I just highlighted, and we also have what we call soft gateways, which are software versions of that you can load on your own server. We have a 2500 license, meaning 2500 unique IP addresses, and then a 5000 license, meaning 5000 unique IP addresses for more of like an enterprise install. And then, of course, we have Velocity touch panels. Now, Velocity touch panels don't have to be our touch panels, even though we do make a 5.5 and an 8-inch touch panel that you can purchase from us. These could be BYOD panels, meaning phones, tablets, computers, whatever you want them to be. ELO touch panels in the case of what we set up for CEDIA and for Infocom. So, you know, this can be pretty much whatever you want. We have an app for iOS, and we have an app for the Android store. So you can download the Velocity app and use that to control different rooms in the house or in a bar or whatever the application might be. And you know, this just kind of covers the products. The VGW250, there's the 8-inch touch panel. We offer that in black and white. And then there's the 5.5-inch touch panel. You know, same deal. We offer that in black and white. Let's say you want to control a device via RS-232 or IR or relay. We do have the ability to do that via what's called VCC modules. These are simple little modules that just hang behind a display or whatever your device might be, and connect to the network as well, but then convert that network signal into IR or into RS-232 or relays or whatever it is that you need to use to control your devices. So, you know, we do offer the ability to control these more legacy devices that are just using IR or RS-232 with these relatively inexpensive little modules as well. And then the software licenses, I covered that as well. All right, so at this point, let's go ahead and just do a quick Q&A. Rick, do we have any questions?
So we do have a couple questions here. So the first question that comes in, can we, I guess to address this, maybe we should pull up the product images.
Yeah, sure.
So the question is about rack mount and the single channel versus multi-channel encode and decode. And the question is to compare it to, I'm not going to mention the brand name, but the a competing model that has 3-channel or 4-channel with a built-in power cord.
Yep.
So it doesn't take away from the PoE budget. How does the Pro and the R-Type address that? How would that rack, and what power would it need? Would it need power from a power supply or from the PoE budget of the switch?
Yeah, so we have a rack mount kit. It's basically a specially designed rack shelf for OmniStream units. It fits 2 OmniStream units side by side. I did mention that these are half RU width, or half rack width, I mean. You know, you can fit 2 of these side by side in a rack on a custom shelf that we sell. As far as power is concerned, you know, you can see here these things have these little orange power plugs here. You can buy an optional power supply for these things. Of course, there's not really a point to doing that unless you just don't have the PoE budget on your switch. I'll say we've certified quite a few network switches for OmniStream Pro and R-Type at this point, and especially in the 1 gig realm, PoE is not particularly super expensive on these switches. And I think that if you went in and you tallied up how much you were going to spend additionally on power supplies to power these things, it would be the same, if not more, to use power supplies. And now you have to find a space to plug all of these things in, rather than having one power supply that you're plugging in for your switch and that powering all of your OmniStream units. So I guess it would be up to the application and up to the integrator, but at the end of the day, I don't really see a reason to use power supplies on these units unless it's just absolutely necessary because you're out of PoE budget on your switch.
Okay, thanks for addressing that. Okay, and then also a question came up for clarification on latency. So you mentioned that the gaming system is the one area where the latency is really going to come into play. Are there any other examples where latency is going to be a significant issue?
Yeah, well, again, I think that really boils down to what your application is. The way that we generally classify these things in the commercial realm is we classify them as in-room or out-of-room solutions. And what that means is that an in-room solution is a solution where you can plug in a laptop and use that laptop in the same room, and watch the screen and not have any significant latency when you're trying to move your mouse around or when you're trying to, do something of that nature. Another good example would be if there is, you think of like a house of worship or something, when there are cameras on the pastor, right? The pastor is walking around on the stage and you have cameras on the pastor and you have these big screens projecting the image of him so the people in the back can see him more clearly. If you're sitting in that room and you can see the pastor moving around and moving his mouth, and you see on the screen that it's, maybe, I don't know, 50 to 100 milliseconds behind, that's going to become very, very annoying and frustrating and potentially give you a headache just seeing those two things be offset so badly. Audio is another example of that. If you have a reference to the original audio, if you can hear that pastor talking, but the system in which his vocals are coming through is being delayed by X number of milliseconds, that's beyond what the brain processes as the same audio source, that's going to become really, really frustrating. Even if you're sitting on the other side of a wall in an overflow room, you can hear the original audio being amplified in the primary room, but you have speakers that are in your room that you can hear the audio through, and it's going through an AV over IP system and being significantly delayed. That's going to become frustrating. Those are just some examples, but yeah, latency comes into play a lot. We really wanted this product to be to match the user experience of an HD-based T system, and I think that's what the majority of people looking at this product are looking for. And with that being said, to do that, you really have to have negligible latency. Otherwise, it's not the same user experience as HD-based T.
Okay, thanks. All right, the next question comes up. It's in regard to the velocity control platform. Does Atlona offer any type of system design, and is there a charge?
Yeah, absolutely. So part of my role also is system design assistance. There's absolutely no charge for that, and I'm gonna scroll back down and put this back up. So that is my personal cell number. I don't know why I put my Gmail on there. That doesn't make sense. That's my personal email address. Let me change that. There you go. So there is my email address and there's my personal cell number. We offer design assistance absolutely free of charge. Now, if you're using the Velocity control system and you purchase a Velocity system and would like for us to do the system configuration for you, we can also do that. If you're new to Velocity or if you're just not comfortable with it, or maybe you're putting together a system that you think is going to be relatively complex in terms of configuring it for control, we will absolutely do that. That is going to be an additional charge. I don't remember off the top of my head what that charge is for our commissioning services, but we can quote that for you. So basically what we usually do is we take a look at these on a case-by-case basis and then quote what we think it's going to cost in terms of labor and sometimes travel time. We can come on site as well. We can do both remote commissioning or in-person commissioning, depending on what you're looking for.
All right, thanks for addressing that. So the next question that comes up is about your audio breakout that we discussed. You discussed both the audio breakout via native cabling right out of the back of the unit, a line level output, and then we also talked about the integration with Dante enabled devices, and then the integration with the AES enabled devices like the QSC. How does downmix work with that? Will it transmit an encoded signal, like a digital signal that a processor could use for surround processing?
Yes, absolutely. Yeah, AS67 enabled surround processor or DSP or whatever, you can pull that Dolby, DTS, whatever signal in and process that there. The only box that we have that does down mixing of multi-channel audio is that Omni 238. So that's the large audio only decoder, the full rack width guy down there on the bottom. That's the only one that we have that does audio, multi-channel audio down mixing. Everything else is essentially just going to pass that that digital audio out to the HDMI embedded output.
Okay, so if we want to pull it directly out of the back of the unit, we want to use the 238. And if the device on the other end of the like the networked feed has the capability to support it over AES, and we can do it that way as well.
Yes, that's correct. Yep.
Okay, perfect. All right, and then any tips or tricks or anything that you'd like to offer for the people who have not done Dante or the kind of the IP-based audio delivery to these DSP products? Because I think that's something that a lot of our guys have questions about, but maybe it seems like a good idea to them, but no, we haven't seen a lot of traction on it yet.
Sure. Oh man, I don't know about tips and tricks. I mean, really, at the end of the day, I'll just say that there's a reason why Dante and AES67 for that matter have been adopted in such a huge way in the commercial world. They work really, really well. They're outrageously fast. I was talking about sub 9 milliseconds for transmitting video in our products. Transmitting audio via AES67 or Dante is like in the nanoseconds. I mean, it's like very, very, very fast. So we're talking about almost zero latency. We're talking about pristine quality audio, multi-channel, even transmitted over the network with very little overhead bandwidth. It's kind of a no-brainer. We have amplifiers now that are Dante enabled. We make a Dante enabled amplifier called the Gain 120. There's interoperability between many manufacturers' products, which is something that you just don't see in a lot of other product offerings. So really, I think, to me, it's kind of a no-brainer to really dive headfirst into this world, because it's one of the only places in our industry where people are actually playing nicely together, and it's pretty refreshing, honestly.
Okay, thank you. Hey, speaking of people playing nicely and supposed standards, what's the support for CEC control through these platforms?
Yeah, so OmniStream does offer CEC. I mean, similar to how we're passing CEC on our Pro 3 matrices and things like that. We're also passing CEC with OmniStream encoders and decoders. So hopefully that answers your question. Is that what you're asking? Just whether or not it passes CEC?
Yeah, so if it's supported, and if it's supported through the control systems or through Velocity or whatever. And then
Velocity does CEC. Yeah, I think I'm pretty sure if you're using one of our products that support, you can enable CEC and Velocity and power things on and off with CEC, simple control like that.
Yeah, I think that's the majority of the application would be like for a video wall, turn all the panels on, turn all the panels off, etc. Or turn the projector on, turn the projector off, things like that.
Yeah, sure.
Okay, perfect. All right, and then obviously the next question, every time someone brings up CEC, the next question that comes up is audio return channel. Is the audio return channel supported in any way?
Audio return channel is not supported on OmniStream currently.
Okay.
And that has a lot to do with the sort of one-way nature of these devices. There are manufacturers out there that are making what's called transcoders. Transcoders being a box that has both an encoder and a decoder built into it. As you can imagine, a transcoder is going to cost you literally twice as much as an encoder or twice as much as a decoder. So it's one of those things where currently we don't offer that because it's not something we've figured out how to make in a way that is reasonable price wise. I think even if we had that product, it would probably be so astronomically costly that nobody would be using it. We do offer audio return channel on some of our new extenders. So if that's something that's necessary for your application, definitely take a look at some of our new HDR extenders because we do have some HDR extenders that are offering that capability.
Okay, perfect. All right, and then the next question that comes up, and this is the most popular question, so we've gotten it from 3 or 4 attendees here. Is there a list of suggested switches that Atlona recommends for the platform?
Absolutely. That's a great question. So on our website, there are 2 documents that I want to point you guys towards. If you go to our website and navigate to the OmniStream landing page, you can literally go to any of the OmniStream products, and this will be on those pages. There is a tab called Resources. If you click on the Resources tab, there are 2 documents. One is the OmniStream IT Deployment Guide. The IT Deployment Guide is a very in-depth white paper that talks about the impact that OmniStream will have on your network. That's a very, very good read if you're interested in, exactly what network specifications we're looking for and what kind of network topologies we're looking for in an OmniStream compatible network. And then we have another document called OmniStream Certified Network Switches, which is exactly what it sounds like. It's literally a list of network switches that we've brought in, certified for use with OmniStream, and then created custom configuration files that you can download from that document that you can literally just push to the network, and then the network is configured and ready to rock and roll for OmniStream. There are switches. We like Cisco a lot just because Cisco is a big name in the commercial world. But we've also got Luxol, PackEdge, Netgear, HP. There's lots and lots that we're working on currently. Some bigger enterprise switches like Juniper and Extreme Networks and lots of other things. So a lot of different switches on there. So definitely check both of those documents out.
All right, thank you. I think that's it for the Q&A today. If anyone has any additional questions, quickly, please type them into the questions tab, and I'll read them off to Seth. In the interim, I want to remind everyone that this webinar and all of our webinars are archived on our AllNet YouTube channel. So if you have staff who you think could benefit from this information, who were not able to attend today because obviously it's the middle of the day and a lot of you have projects active right now that you're trying to get closed out. So you're welcome to direct them to our YouTube channel, and it's youtube.com/allnetdistributingu, the letter U at the end. And all of our content is usually published there. Usually it takes 2 to 3 days for us to edit it and get it posted. So But we would invite you to consider liking and subscribing to the YouTube channel, as well as our other social media platforms, Facebook, Twitter, etc. Seth, do you want to plug any of your resources or pages?
Yeah, absolutely. What one thing I can't recommend enough to everybody who attends these types of things is we have loads and loads and loads of free training on our website that is totally invaluable. www.atlona.com/training, or if you just go to the Atlona website and click on training. You can request login access, and somebody will get back to you within 24 hours with login access. And then, we have an OmniStream technical training, an OmniStream sales training, a velocity training course. We have training videos that show you how to configure our video wall system, so you can go in and see just how simple it is to configure that. We have 100 and 200 level basic AV trainings that go over just AV basics. If you want to, learn more about AV in general, the 200 level dives more into our product line and our product offerings. Lots and lots and lots of resources. As well, on the training website, you can find a webinars page where all of our webinars are posted, just like Rick was saying, AllNet's going to be posting this guy. We have the same thing. So just loads and loads of stuff that I highly recommend you guys going in and taking a look at. And then lastly, our YouTube channel. We have tons of YouTube videos up. Training videos, and one of our training manager, Ken Eagle, does these boxes called, I think they're called Out of the Box or something like that, where he unboxes products and shows you exactly what comes in the box with a lot of products that we're offering. All sorts of stuff if you're interested in that kind of thing.
Perfect. And yeah, I can definitely attest to the value of the Atlona training system, because I am myself 100 certified, 200 certified, and then also certified in, I think, Velocity AMS and OmniStream are the ones that are outside of the 100 and 200, correct?
Yes, correct.
Yeah. So, well, Wally asked us to review it. So pretty much everyone at AllNet is 100 and 200 at least. So, all right, Seth. Well, I want to thank you for taking the time today, and I want to thank everyone on the call for taking the time today to join us. If anyone has any questions, it looks like the questions box hasn't had any new entries, so please feel free, if you have any questions after the fact, type them and submit them either to me or to Seth, and we're happy to get back to you. And if you have any projects that are in the pipeline and you'd like to consider this product, reach out to us or reach out to one of your AllNet sales staff, and we'd be happy to help draft up a quote on the OmniStream family to see if we can help you put some Atlona products in these projects. So thank you again for taking the time, and we're going to go ahead and close the call now.
Thanks a lot.